Okay, so what we're going to look at today is optimizing area and perimeter. Now, what optimizing means is we're finding the best, the ideal, or best area and perimeter. Okay, if you were optimizing a play area, you want the maximum or minimum play area. Well, we'd want the maximum play area because we want to have the most room to play. Okay, if you were trying to find the optimal amount of fencing to make that maximum or minimum, you want to have the minimum perimeter. You want to have the least amount of fencing because that's going to allow you to have less money invested in the fence. The smaller the fence with the more area is going to give us more room to play for a cheaper amount. So if we had something like this, if we considered the rectangle that we have here, we've got 20 units of perimeter, and we're going to find the length and area. Well, if I start with something like 9, let's just use whole numbers. Okay, 9 and 1, that would be 10. We have to times it by 2 because remember, if we're making this square or rectangle, we'd have 9 and 1, but we'd also have 9 and 1. So any of these, we're going to add them together and times by 2 to come up with our 20. So we really need the two values to add to 10 because then when we times them by 2, that's going to give us our 20. So the area here is going to be 9 meters squared, or 9 units squared, I should say. Now the next one would be 8 and 2, and that's going to be 16 units squared. The next one's going to be 7 and 3, it's 21 units squared. 6 and 4, 24 units squared. 5 and 5, which is actually a square, it's 25 units squared. And then if we were to actually keep going, we'd go back to 4 and 6. This is just a repeat of this. Our length and width, well, we're kind of conditioned to think that width is shorter than length. They're just representing two sides of a rectangle. It doesn't actually matter which one's longer. But these two are just a repeat of one another. And what we can see is this is actually giving us the best area for the same amount of perimeter. It's optimizing our perimeter. So if we were looking at this, the dimension that's giving us the maximum area is going to be 5 by 5. Okay, and that's 25 units squared. Well, what if we were making a fence that only had 2 meter sections? So a lot of fences come in specific sections. So in this case, let's say they were 2 meters. Well, what we're going to have to do is we're going to have to go back and look. And we're going to say, well, it's either going to be this or this. Okay, because these numbers are the next biggest, and both 4 and 6 can divide by 2. So if we were looking at this, it would be 4 by 6. Okay, that's just us putting some sort of restriction on the answer. Now the last one is like, what if we had rope instead of fencing? Well, if we had rope, that would mean that we could make a circle. So we know that the area of a circle is pi r squared. Now if I had rope, I need to find r, but we can find r by using 2 pi r, knowing our circumference. And well, we know what our circumference is because we know that our circumference is equal to 20 here. So if we divide 20 by 2, we get 10. So we're going to have something like this. We can have 10 pi r, and then if we divide 10 by pi, we're going to get r is equal to 3.18. And there's a whole bunch of decimals after that. Well, now I can take that r and sub it in here, and you're going to see that if we could make it our fence with a rope, we would actually get the best number. What we're going to get is when we square that value and then we times it by pi, we're going to end up with 31.83 units squared, which is actually significantly bigger than our best unit when we kept everything as straight edges. All right, so if we keep moving along here, if we were to look at these, so now we've got like a different one here. Now we've got 24 units squared, so we're making a rectangle. So what we need to do is we know that length times width is equal to our area. So really what we need to find now are our length and width don't have to add up to half of our perimeter. What they have to add up to is a multiple, oh, not 26, 24, that's going to multiply to 24. So we could start with something like 24 times 1. 24 times 1 is going to give us 24. Remember, if we have a length and width, so we've got 24 and 1, we also have 24 and 1. So we have to add them together and double them. So this would be a perimeter of 50. So if I had a length of 24, I'm going to put it on the graph here, I've got a perimeter of 50. Well, let's make our width 2. Okay, so that's going to make this 12, because 12 times 2 is 24. Now we have to add those together and double it. So 14 times 2 is 28. So now we've got a width of 2, but a length of 12. And we're at 28. So length of 12 kind of goes in that neighborhood. Next, 24 is nice because it actually divides by a whole bunch of things. This is going to be 22. So we've got 8. It's going to 22. And then 4. It's going to be 6. And that's going to be 20. And then it actually doesn't divide by any more numbers. So what we have here is we have the next one we'd be looking at would be 6, because 24 doesn't divide by 4 or 5. So we'd have to go to 6, and we're back up to the same value. We're back up to 20. So our length here is 4. We're back at 20. If we were to keep kind of going here, our next one would be a width of 8. And then we're back to 3, so we've got 24, and that's where we had the 22. So we'd actually be kind of moving our way back up like this. Okay? So our best value is kind of right down here. We're going to use the first one. We're going to use this. A length of 6 and a width of 4. So which one gave us the optimum? Well, that's kind of easy to see. We've got the length of 6 and the width of 4. So 6 by 4. Now, I don't know if you've realized this yet, but what we're looking for is we're actually aiming for a square every time. If we can make a square, if we look at the first one, it was 5 by 5 or 6 by 4. If we look at the next one, it was 6 by 4, which is as close to a square as we could actually get, because 24 doesn't divide evenly. So in all of these cases, we're aiming for a square. So the next thing is, if we had 100 meters of fencing, what dimensions would give you the largest possible area? And what is the maximum area? So what we're given is a perimeter is equal to 100. Well, if we're looking for this to be, or 100 meters, excuse me. If we want it to be a square, well, the perimeter actually equals, for a square, 4 times the side length, or 4 times s. So then we know 100 equals 4 times s. So then I can just divide both sides by 4 and find that my side lengths are going to be 25 meters. If I know my side lengths are 25 meters, I know that this should be 25 meters by 25 meters. That's my optimal dimensions. Okay, that's the best dimensions. So ideal dimension. However, to find my area, I actually need to multiply that then. All I'm going to do is multiply those together, and we're going to get 625. That's going to be meters squared, and that is your max area. Okay, we're always looking for that square. Now sometimes, like that other question, we put restrictions on it and it can change things. But in this case, we haven't. All right, so let's look at another example. So you have 9 bunnies. It is recommended that they each have 1 meter of space. What is the minimum amount of fencing you need to make a rectangular enclosure? So it has to be a rectangle, it can't be a circle, that will hold all 9 bunnies. So this means we have an area of 9 meters squared. Okay, we know we have to have that 1 meter per bunny. We've got 9 bunnies. Okay, to find our, so if we go back to the last question, we just squared 25 to find our area. Well, to find the ideal dimensions, what we're going to have to do is we're going to have to take our area is, well, it's equal to our 2 sides squared. So then our sides are actually going to be the square root of our area. And in this case, it's the square root of 9 equals s. That's going to be 3 meters. It's going to be s. So then 3 by 3 is ideal. And if you don't think that you're correct or you're concerned that you're not right, just multiply them together. Okay, 3 times 3 is 9. That's going to give us the optimal area. Okay, so 3 by 3 is there. If we wanted to find the minimum amount of fencing, though, we need to fence the whole thing. Okay, so we need to go 3, 3, 3, and 3. So the perimeter would be 4s, which is 4 times 3, which is 12 meters. So you'd have to buy 12 meters of fence. Okay, so we've done 4-sided shapes, but a lot of the times we don't have 4-sided shapes. A lot of the times you have 3-sided shapes. Like think of your backyard or a backyard that's blocked off by a house. Or in this case, you've got 100 meters of rope to enclose a rectangular swimming area in a lake camp where you work. 3 sides of the rectangle will be used with the rope, and then the other side is going to be the beach. So draw 5 different rectangles to kind of show how we would use the full thing. The first thing that people think of is like, here's the water, and then we've got our rope. First thing people think of is, well, why don't we divide it 3 ways? So 33.3, we'll just pretend that this actually adds up to 100. And we'll call this one 33.3 as well. Okay, we'll pretend that that's close enough. The area here, 33.3 times 33.3, is roughly this. And this would be meters squared. Okay, pretty close. 1,108.9, almost 1,109. Okay, that's our first one. That's what people roughly think. But very quickly I can prove to you that that's not the best way. If we do something like 20, 60, and 20, well, we do length times width there, we're going to get the area equals 1,200 meters squared. Well, that's bigger than 1108 or 1109 even. Well, what if we did something like this? Like here's another one. Let's see, if we keep going smaller, we've got 10 and 80. Well, 10 times 80 is going to be an area of 800 meters squared. Well, that one's not any better. So this one's no good. This one's no good. Well, let's try another one. What if we did something like, I don't know, 40, and 20? Well, that's again going to give us an area of 800. So that one's no good. So far it's that 20, 61. Well, let's go kind of in the middle there. Let's split the difference here. If we did 25, 25, and 50. Well, 25 times 50 is going to give us an area of 1250. Okay, now that's actually our best area. Now if we did one less, or we have to do two more, okay, so if we did one less, we'll do a couple more shapes here. If we did one less, we'd have 24 times 52, which is going to give us 1246, okay, which is smaller. But if we did 26 times 48, it also gives us 1246. So in both cases there, we're getting smaller. So this is actually our optimal or ideal way of doing this. So calculate the area of each and which one has the maximum. Could we develop a formula? Well, if we were looking at this, we've calculated the area of all of these. We put it on there. Now the maximum was the 25 by 50. So what our formula here is, if we think about four-sided shapes, we've got something like this. So side, 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 and we try to make them a square. If we think about a three-sided shape though, we've got side, 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 and side. Okay, now what I'm going to do here is I'm actually going to do a little rejigging. We're not really changing the dimensions, we're changing where they are. Okay, I'm taking that other side out and I'm putting it right there. So if we had this side being the red one, what we're doing is we're taking it, and we still have side, 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 but we're taking it and moving it up. Okay, so the formula for this, we could say the length is always going to be equal to 2 times the width. Okay, and the width is always going to be the same as what we had before. The width is equal to the perimeter divided by 4. Okay, so we know all of these different things. We've got perimeter divided by 4. Well, what that means is the length is then actually equal to the perimeter divided by 2. Okay, so when enclosing four sides, always try to get a square. So the area is equal to the sides squared, and the perimeter is equal to 4s. Okay. When we're looking at a three-sided shape, there's a little bit more to it. We know all of this stuff that we've kind of put up here. So the perimeter is going to be equal to, well, it's going to be equal to the length plus 2 times the width. Well, we know the length is equal to 2 times the width. We just wrote that right here. Okay, so this is 2 times the width plus 2 times the width, which is actually 4 times the width. So the perimeter is 4 times our width. Okay, now the area is a little bit different. The area is going to be equal to the length times the width. Well, we know the length is 2w. I tell you guys all the time not to use the x, and then I go ahead and do it anyway. So let's change that. We've got length times width. So this is going to be 2w squared is going to give us our area. Okay, now if you don't memorize your perimeter is 4w and your area is 2w squared, you can use those other formulas and actually figure this out. All right. So again, if we had something like this, if we had our beach and we were going through doing this, we could have something like 50, 25, and 25. We could have 30, and then 35 and 35, or 36 and 32, or 20 and 40, or 40, 30, 30, 40. There's all sorts of different ways that you could do this. But what you need to recognize is we're always going to come back to this way. If you were to do area equals length times width, all of these have the same perimeter of 100. And you're going to find that that top left one is going to be our ideal situation. So if we looked at this next example, we've got 60 meters of fencing. What is the maximum possible area if you enclose 4 sides or 3 sides? Well, for 4 sides, if we've got 60 meters of fencing, that means we have to find the side length. 60 meters of fencing is telling us the perimeter. That's 60 meters. Well, that means that 60 is equal to 4 times S, and then S is equal to 15. Well, it's asking us what the maximum area is, so we have to then say area is S squared, which is 15 squared, which is 225, and that's meters squared. Okay, well, if we have the 3-sided shape, there's the 4-sided shape. If I was doing 3-sided, it's a little bit different. We know that the perimeter is equal to 4 times the width. Not necessarily 4 times a side, because the 2 sides are different, but 4 times the width. So we know that the width is then going to be equal to 15, but the length is going to be 30, because the length is 2 times the width. Well, our area then is going to be equal to 15 times 30. And it makes sense that we're going to have a little bit extra space because we've got that extra rope. One of the sides is being blocked in by, in this case, let's say a house. But like in the last case, one of the sides was being blocked in by the beach. So what this is actually doing is doubling our area. Okay, so our maximum area here is going to be 450 meters squared. Let's look at this last example. So you need to enclose 3 sides of a 40 meter or square meter area. Okay, the 4th side is going to be enclosed by a river. So what is the maximum amount of fencing required? So what we're doing is we know our area is equal to 40 meters squared. Well, we know if we're doing 3 sides, we talked about before, that our area is 2w squared. So area equals 2w squared. So 40 equals 2w squared. 40 divided by 2 is 20 equals w squared. And then the square root of that, or 20, is going to give me about 4.4, let's say 7. And now that's going to be our width. So our width is 4.47 meters. We know our length is double that, so our length is 8.94 meters. And so what is the minimum amount of fencing? Well, the minimum amount of fencing is going to be our perimeter. And our perimeter is length, 8.94, plus 2 times our width, 4.47. And if we add all of that together, we're going to get 8.94 plus 8.94, which is going to be 17.88 meters. Okay, and that's our final answer. That's the min fencing is 17.88 meters. Here's some questions for this.